lists state which is continuous and which would be discrete. So we're looking at two different types of concepts, continuous and discrete. But before we actually get into define these, why don't we review quickly what each one is. Now if we're looking at discrete are entire whole numbers. They're things like people. For example, you can't have 1.7 people. That's not possible. You have one person or you have two people. Or there are things like items. You cannot have 2.3 cell phones. So people and items. And if you were to graph them, it would look like nice whole numbers. You'd have 3 people, one would leave. You'd have 2 people, another one would leave. You'd have 1 person. There are solid points on this graph indicating a change. Now continuous is a little bit different. Continuous are things that you tend to measure. For example, they would be things like weight or height or quantity of liquids. So let's actually look at that. Let's say that you start here with 12 ounces of a liquid. As you pour it out, it goes down, and then you stop pouring and it levels off. This would be an example of continuous. There's not a place that you have a sharp edge. Thus the reason it's called a continuous or discrete. So we're going to start by looking for continuous. Weight, we've already identified, is continuous. Family size, however, deals with people. And people, as we know, are discrete variables. Number of cars. Okay, cars is an item. Therefore, this is discrete. Speed. Think about when you're driving your car and you accelerate and then you brake. This is not a sharp edge. It is a continuous curve. Height, we've also already identified, is also continuous. And number of cell phones. Now, there are 2 indicators there. Cell phones is an item. But generally, whenever you see the phrase number of something, it's generally a discrete variable.